So myself, Dr. Santosh, is hosting this session. Welcome all of you to the last day of this online ATAL FDP program, and good afternoon all of you. Greetings from ITAM. I take the privilege to introduce Sri Avinash Garu, who is the resource person for today's very first session on the topic Lean Manufacturing in Industry 4.0. Sri Avinash Vantaram Garu is an engineering and business leader with over 2 decades of experience in global operations, strategic initiatives, and lean enterprise management. He holds a master's in mechanical engineering from West Virginia University, an MBA from California Lutheran University, and bachelor's in mechanical engineering from Andhra University. Throughout his 20 plus year tenure at Pentair, he has progressed from a design engineer to key leadership roles, including Director of Operations and Segment PMO leader. His expertise lies in process optimization, operational excellence, and enterprise transformation, making him a strong force in the manufacturing and engineering sectors. Now I request Sri Avinash Garu to take over the session. Go ahead, sir.
Thank you very much for the introduction. Again, hello everybody. Good evening. I think it's evening for you. I'm talking from California, so it's a little late in the night for me. I hope everybody had a wonderful Saturday and some pretty good sessions today. I believe there's more sessions later in the day as well. First of all, I'd like to thank Dr. Srihari for inviting me to share some of my background and my experience with this esteemed audience. I'm very honored to be invited, and today's topic is around lean manufacturing and how lean applies to Industry 4.0. So we're going to be doing a case study, and I'll be presenting the case study of the company that I currently work for, which is Pentair. Pentair, over the last 15 years, we started our lean journey, and we progressed from a company that was very traditional manufacturing into a lean startup and a mature lean organization that is just getting into the Industry 4.0. So this case study is about Pentair and how that journey progressed over the last 20 years. So as I'm talking, if anybody has a question, please feel free to interrupt me. I have a lot of slides, but there are a lot of pictures. So this is not going to take a lot of time. So in case anybody has questions, it's just interrupt me, stop, and we can talk and discuss more if needed. First, a little bit about the company. So Pentair, it's an S&P 500 company, presence in about 150 countries. Last year, 2023, the revenue of the company was about $4 billion, about 10,000 employees. The company has been recognized over the last few years. It was voted one of the top 100 sustainable companies in the world. 2025 Innovation Award, Forbes Top 100 World's Most Innovative Companies, America's Best Employers, and so on. The company operates under 3 segments, namely Flow, which makes heavy industrial pumps, Water Solutions that make water purifying equipment, filtration products. All the Starbucks, all the McDonald's in the world use the filtration products from Pentair. And Pool Equipment. It's the world's biggest manufacturer of swimming pool equipment. Some of these products, Pentair makes the biggest reverse osmosis unit in the world. All the U.S. Navy equipment use the reverse osmosis equipment from the company. It exists in commercial and residential industries, agricultural and industrial as well. So you can see some of the examples of the products that the company makes. So the company started in 1966 and started as a small company with less than 100 employees, and the company grew through acquisitions. So as the years progressed, we acquired multiple companies. There are over 100 acquisitions that happened over the last 15 years. And what happens with acquisitions is you have different microcosm of cultures within the organization. No two different plants, manufacturing plants within the company have the same culture, right? Everybody thinks different. Everybody has a different vision. Um, all the processes are different. There's no standardization anywhere, right? So that's how the company grew, and it grew very aggressively, right? So there were multiple acquisitions that happened every year. And what that did is it created a lot of chaos and a lot of disorganization in the company. So that's what drove the company towards, this is not working, something has to change. And that's what started the lean journey for this company. And the lean journey started in around 2003, 2004. But before we go into the lean journey, I just wanted to know, I'm pretty sure all of you have have a lot of experience in lean, but there may be some people that probably do not understand lean a lot. So I'd like to give a quick introduction of what lean manufacturing is. Basically, lean is nothing but, and I apologize, my slideshow is just moving automatically, so I'll have to keep moving back. But basically, lean is nothing but waste elimination. Take waste out of a process and then make sure that we are continuously improving, right? So we're never satisfied with current state, and we're always looking forward to the ways of improving processes. Now, what is waste? Believe it or not, waste can be classified, right? There are 7 types of waste that we can identify. Now, why do we need to classify waste into these 7 categories? The reason why these 7 categories were specifically identified is because if I say inventory is a waste, that's one category of waste. Every time you look at inventory, you know that is waste. You have piles of inventory sitting on a shop floor. That is not adding any value to your customer. If you say motion is waste, when you're moving product from one place to the other, that is a waste. So every time you look at somebody moving an item from one bin to another bin, you know that it is waste. So it is very important for everybody to know what are the 7 kinds of waste. So when you see that activity happening, you can identify that as a waste. Now, every single operation within manufacturing can be divided into 3 categories. One is value add, anything that your customer is willing to pay for. When you're transforming a product or you're transforming information, that is value add. Your customer wants to pay for that activity. There is another activity called incidental work, necessary non-value add, right, or incidental. What that is you're not truly transforming product or information, but you need that activity to perform a job. For example, compliance requirements, right? Compliance, you're truly not adding, you're not transforming a product, but you absolutely need to abide by the rules and the compliance requirements of the government or the different organizations that your products are certified under. And the third category is non-value add. Non-value add is anything that is not transforming the product or that is not absolutely necessary for you to add value to the product. For example, moving product from one end of the plant to the other of the plant is non-value add. Carrying inventory more than what you need to produce is non-value add, right? So the red part, what you're seeing on the screen, is the non-value added product that you need to take out of your processes. That is called waste elimination. And lean is nothing but the relentless pursuit of removing that non-value added activities out of your manufacturing operations. It doesn't need to be just manufacturing. It applies anywhere. It applies to software development. It applies to office space. Anywhere you have transformation going on, you will have lean principles being applied. Now, the topic for today was lean manufacturing in Industry 4.0. Now, what is Industry 4.0? Industry 4.0 is the fourth industrial revolution. That's why it's called the 4.0, right? So there have been four industrial revolutions so far. The first industrial revolution is in the 18th century, 1766, is when mechanization using steam and water came into being, and people started using that kind of energy to start producing product. Second industrial revolution happened in the 19th century when electricity was invented. That enabled us to start mass production. This was in the mid 1800s. Then the third industrial revolution started in the 20th century, which is the last century, right? When computers were invented and automation started coming into the workplace. We started seeing a lot of work being done through computers, where in previously we had like paper, pencil to do a lot of record keeping. Everything's happening on computers right now. We started introducing robots into manufacturing environment. Now, those robots were individual, they work by themselves. But now in Industry 4.0, we have the next revolution that is happening, right? Artificial intelligence, networked systems talking to each other, connected systems, right? Big data that you could use, and systems that can read that big data and interpret that information and make decisions for you, or provide information that you can make intelligent decisions and on-time decisions with that information, right? That's Industry 4.0. There's a lot involved with Industry 4.0, still evolving a lot, right? The technology is changing day by day. We'll be talking more about digital factory and how big data is being used to enable that real-time decision making within that Industry 4.0. So now, the case study we'll be talking about is how Pentair moved from being a lean-focused company to a lean-focused company in the Industry 4.0 period. Now, some of you might have heard the Shingo methodology. Now, lean, Shingo is one of the lean principles, right? So, lean, when we spoke previously, it was about waste elimination, right? How do we take waste out of the process? It's not just taking that waste out, right? So when we talk about Shingo methodology, it's one of the lean thought processes where you're focused on process improvements, creating systems and processes that are sustainable, but you're developing the culture to make sure that the processes that you're creating are effective as well. So there are two legs when it comes to Shingo, right? You're working on your processes and systems. At the same time, you're enabling the culture to make sure that continuous improvement is not just a fad. It's not just a thing that you're doing. So when you're enabling the culture and developing the processes hand in hand at the same time, that's what sets you up for successful future. That's what the Shingo methodology is. And more companies are transitioning towards the Shingo methodology, right? Again, this is what I mentioned is a very high level, but more companies are moving from the basic lean methodologies towards the Shingo lean methodologies, where you're focusing more on the people and leadership and not just the tools and systems that are being used. So the reason why Shingo is important is because at one point, Pentair, in our lean transformation, we moved towards the Shingo methodology, and I'll talk about a few benefits that we achieved through the Shingo methodology. So to start off with, I'll introduce the House of Lean, right? So Pentair, which we start using a system called the PIMS, which is Pentair Integrated Management System. It is based on the TPS methodology, which is Toyota Production System, or the Danaher Production System, right? So there's TPS, there's DPS, there's PIMS. So all these systems have a basic methodology, right? We start with a high-level strategy, right? What's your long-term strategy? What's your short-term strategy? How are you going to get to your 5-year vision through 1-year increments? That's strategy deployment, right? And once you have that strategy, how do you deploy that strategy across the organization? I'll touch base a little bit about it in our journey. So once you have strategy deployment defined, that's step one, right? Without a strategy, you cannot start your lean journey. Where do you want to take your company? Once you define that, then you identify how do you transform your organization to meet that strategy, right? What's your long-term strategy and what's your long-term transformation plan? But how do you break it down into 1-year increments? What's your plan to go from year 1 to year 2 strategy? And how do you get there is transformation planning. Then you got workplace organization. In other words, there's also 5S. 5S is 5Ss. Then standard work, creating standard work, making sure that whatever you do follows a standard. If there is no standard, there is no room for improvement. You need to standardize the work. If you're doing an activity, you need repeatability in that activity, right? Every time, for example, you have a lot of industrial engineers on this call. Time studies, right? When you're doing time studies, there needs to be a repetition. You cannot do one activity for 50 seconds. The next time it's 5 minutes, and the next time it's 3 minutes, and next time it's 5 minutes. So with that variability comes a lot of issues, right? First, standard work, make sure that you're standardizing the process. You're taking the variability out of that process. That's standard work. Step 5, once you standardize the process, is creating flow right within the organization, creating flow within that manufacturing cell. How do you make sure that inventory is not getting stuck from one station to the next station? That there is a one-piece flow happening between the different operators or the different machines that are working. Once you have that one-piece flow, then you go into how do you make sure that material is flowing from outside your organization to inside your organization, that there are signals that are happening. So you're not piling up inventory either at your suppliers or at your warehouses or in between your suppliers and your warehouses. So how do you make sure that there are materials that are flowing, right? And there are various concepts for each of these that lean companies use to make sure that we are optimizing each of those processes. Then visual management, right? How do you make sure that if there's an abnormality, that abnormality is clear and you can act on it. So it is very important to make sure that you're checking your abnormalities on a daily basis, which is called MDI, managing your daily improvements, checking your metrics on a daily basis and act on it if you're not meeting your goals. So that's a 7-step process that within Pentair we follow, and it goes through a PDCA cycle. So for those of you that are in the lean system, you use PDCA, plan, do, check, act. If you're in Six Sigma, it's DMAIC. But we use the PDCA, the 4-step plan, do, check, act cycle. So you plan for something, you implement that plan, you check and make sure that your plan is working. And then if there are any discrepancies, abnormalities, you adjust your process, you act on those findings. And you plan again, the cycle continues, the cycle never stops. This is the continuous improvement model, right? So even in this 7-step strategy that I spoke about in this house of lean, once you get to that 7 stages, you repeat the process again, plan to check, act. You create new strategy, you create a new transformation plan, and your cycle repeats again. So within Pentair, now I'm going into the journey of the company that I work for. So we started our lean journey in 2004. So we created our first, what we measure in 5-year cycles, right? So our first lean cycle was from 2004 to 2008. So we created that first vision on a 5-year cycle. Year 1 to 2 is a stabilization turnaround kind of activity. Year 2 to 3 is creating a flow within the plant. Year 3 to 4 was connecting our suppliers to the plant and the plant to our customers. And year 4 and 5 is continuous improvement. How do we make sure that that cycle does not get stuck and we keep on moving forward? After the 5th year, we came up with a new lean strategy, right? So the first 5-year strategy was more around stabilization. The second 5-year strategy was more around culture and culture enablement, right? That's the Shingo methodology. Then the third one is about automation, and 2014 to 2019, so automation and making sure that we're improving the safety within the organization, taking off some of that excess motion that the employees are performing by introducing robots and robotic equipment. And then the 4th cycle, which we are in today, from 2020 to 2025, is that Industry 4.0, right? Connected systems and how do we have all these different systems talk to each other, and how do we use big data, right? How does ERP, enterprise resource planning, play a role in all this? So that's the 2020 to 2025 cycle that we are in right now. So quickly touch base on the latest cycle, and then we'll go start the journey. So this is the 2020 to 2025. This is where we started to look at a digital factory, right? Started to look at that connected automation systems, tugger routes, which are material movements within the 4 walls, right? Today, there are drivers that drive our forklifts, drivers that move material from one side of the plant to the other side. We now have automated tuggers that actually move material without any people being involved. They come, they stop, and automatically pick up material from the production lines and to a shipping area without manual intervention, right? So that's the Industry 4.0 journey that we are currently on. So in our case study, we'll be talking about one of our plants. Pentair has multiple manufacturing plants. We've got about 46 manufacturing locations across the world. We will be talking about the location in Moore Park, which is close to Los Angeles, California. We're about 30 miles from Los Angeles. So this company had about 500 employees working, is about a 300,000 square feet enterprise. Now, I apologize. I'll be talking in the FPS system because that's how I'm used to it. It may be a little hard for some of you to maybe convert units. So please stop me if you need any clarification there. This company ships out about $1 billion worth of revenue in a month and is one of the most profitable sites within the company today. But in 2004, this Moore Park facility was truly struggling. This plant had about 120 days worth of inventory sitting in the plant inside the 4 walls. And they were only delivering a 50% on time to their customers. So way too much inventory, and only 50% of the time they were delivering to their customers. It was hemorrhaging money. It was not making any profits. It was losing money. So there was even a discussion around, okay, is this a viable enterprise? Is this a viable business? So in 2004, leadership team got together and said, okay, you know what? We got to turn this business around. There is this thing called lean that a lot of companies are trying. So let's build our lean team together, and we'll start our lean journey, and we'll take waste out of this plant. So in 2004 was when PIMS, the Pentair Integrated Management System, was put together at this plant. A team was put together. People from other companies that were brought in, from Toyota, from automotive that were brought in to come up and understand where we are. A lot of outside consultants were brought in, understand where we are, understand where the company needs to go. So the first lean roadmap was put together in 2004. Okay, so this is that 5-year plan that I was initially talking about. Year 1 and 2. how do you stabilize this organization, right? There were a lot of opportunities. The bill of materials were wrong. Inventory was inaccurate. People used to go to find inventory, and inventory is not in that location. So inventory control was minimum. So there were things that had to be done year one to stabilize, right? To put audits in place, to make sure that there are bill of material audits, there are cycle count processes that are in place. And then once you have stabilization, then the 5-year map can be implemented, right? You can then look at each of the production lines and make sure that you're taking waste out of the production lines. But year 1 and 2 was around stabilization. And the first thing that we did at that time is we used our step number 1, strategy deployment. Came up with our 3 to 5 year vision as to where we want to take this company. And that 3 to 5 year vision, it includes, okay, what's the revenue growth that we are expecting over the next 5 years? What's the income growth that we are expecting, or profit growth that we are expecting in that 5-year period? What kind of activities, processes that we need to focus on to get us to that 5-year vision? That's strategy deployment. So that strategy deployment, it's also called Hoshin Conry, right? The Japanese term for strategy deployment is Hoshin Conry. A Hoshin Conry tool was first introduced to this company at that time. You come up with your 5-year strategy at your bottom. This is your breakthrough objectives. Then you break down your 5-year strategy into your 1-year goals. To get to this 5-year, these are all the one-year goals that we need to get to. To hit these 1-year goals, these are all the processes that we need to focus on to improve. And to make sure that these processes are working, we need to measure success of those processes, or targets, right? These are the targets that we'll be using to measure if the process is successful or not. Once we define those targets, then we create a bowling chart, right? A bowling chart is nothing but a scorecard, right? So you have multiple scorecards. You measure safety, quality, delivery, your performance to cost, your inventory levels, your cash position. All that is measured and put into bowling charts. A quick check. Can you all hear me?
Yes, sir. Yes.
Okay, thank you. I wanted to make sure. So once you have these bowling charts, then you break it down into your 12-month targets, and you measure performance every month, and make sure that if you're missing your targets, you're doing your root cause analysis, countermeasures to those root cause. So this was the first step. Define your objectives, define your goals, and measure your goals. Once you have that, then you cascade it down the organization. So we started doing this at the corporate level, then, which is called L1, right? The L1 strategy, which comes from the CEO of the organization. Then we break it down to an L2 strategy, which is at the segment level, right? So one level down from the corporate enterprise. One, that is the L2 level. The segment creates their segment strategy. So we have 3 segments. Each segment creates their own strategy. Then that L2 then goes to an L3 level, which is at the plant level. We've got 46 manufacturing locations. So each manufacturing location has their own L3, which is at the plant level. Then you break down the plant level to an L4, which is at a value stream level. So you cascade that strategy down, the actions down, from the CEO's vision to the point of impact, which is at the cell level. Right, so this is called the cascading of that strategy. It is the key part of that Hoshin Conry. So when we first started in 2004, these were some of the examples that we saw on the production floor, right? So you see, a couple of operators working in this area here. There's inventory all over the place. There's no inventory control. There's no flow. Doesn't look like there's a standard process. You can see scrap all over the production floor. Everybody's working at their own pace, right? There's no measures, nothing. Again, no inventory control, right? So this is what used to be the receiving area, right? So material coming in and just sitting, waiting to be processed. This is what caused 120 days worth of inventory at that time, right? So how could anybody find what they're looking for in that area? Finished goods, right? Same thing, right? We used to build product and put it into our warehouse. Our warehouse was full of racks, and we built the product to orders. But when it was time to ship the orders, our order pullers were not able to find inventory. Inventory was missing or was put into a wrong location. So there's no inventory control in our finished goods market. So in lean, the biggest waste that you can have is inventory, excess inventories, overstocks, overproduction of that inventory. So our first goal is to bring those inventories down. So what we did in 2004 is we went to our step number 2, which is transformation planning, right? We have our strategy and we wanted to create a transformation plan. How do we get to that strategy? In order to create a transformation plan, we use what is called a value stream map. We have to create a map that is on paper that shows your process from the beginning to the end. It's called a value stream map. How is the value flowing within the organization? It shows the flow of products, flow of material, and the flow of information across the organization. So the first step that we did is create a value stream map. Now, the key use of this value stream map is because you're walking the process end to end, you are actually doing this on the production floor and identifying everywhere the product is getting stuck, everywhere that you are seeing a waste. So what you see in some of these bursts this is called a Kaizen burst, right? So these are all opportunities that whoever created this map identified at that time. So the key reason why we do a value stream map is to find what those wastes are and note those wastes on your value stream map. So first you create a current state map. How is your process in the current state? Then you identify those opportunities, which are the Kaizen bursts that I showed. Then you create an ideal state map. Ideally, how do you want this process to look like? Ideally, how do you want the product to move within your factory? And in ideal state, there are no constraints. You assume that you can do whatever you want. You can dream. It's your dream, right? So once you create your ideal state, now you come back to reality. You know that ideal state does not exist, but that gives you a vision what you want to do. Once you create that vision, once you create that ideal state, then you come back and get with the team and create a 12-month future state. I know my current state. I know ideally how this process is going to look like. I may get to an ideal state in 20 years, but what's my process going to look like in the next 12 months? That's my future state map. So we created a future state map and then identified the barriers that exist from us getting from current state map to the future state map, then created a transformation plan to remove those barriers. That's called transformation planning. That's step number 2. The transformation plan is at the site level, and then it is all those key projects that you need to execute to get your plant from your current state to the future state. So transformation plan was created in 2004. You could start seeing that, we started bringing our racks down. We decided that having racks in our warehouse is not a great idea. First of all, you need forklifts to be moving material. If you have racks, that means that you're limited with the number of people that can actually touch the product. So they started taking the racks down. These are finished goods. So now all our order pullers have access to the product. They do not need expertise on heavy equipment, material handling equipment to move inventory around. A little bit of an organization, you start seeing a little bit of that organization, right? Still not great, not very well organized, but at least there's a little bit, material is organized in rows that you start seeing FIFO, right? These rows are all the same product. You pull from one end, you feed from the other end. We start, in 2004, we started taking inventory out of the production lines. Now, you saw in one of first slides that there was a lot of inventory. Started pulling that inventory out of the production line, decluttering the production line. So that way, first of all, it's more safe, more organized, and it's easier to see waste when your lines are decluttered. So this was about 20 years ago. Now, 2005, the year after, once we created a transformation plan, we started executing it. The first step of this execution, just because you created a transformation plan, nothing's going to happen. Just because you created a value stream map, nothing is going to happen, right? These are just plans. You got to start executing them. The first execution is what is called 5S, right? So this was step number 3 in our house of lean. So 5S is workplace organization. This is where you take you organize your workplace, so everything is easy and within reach. So we have a rule, the 17-second rule. Whatever you're looking for, it could be a file on your computer, it could be a physical file that you may have in your office, a drawing that you're looking for. You have no more than 17 seconds to find it, and it's an audit criteria for us, right? If you take more than 17 seconds, you fail your audit and you need to reorganize your stuff. So this 5S applies to both your physical workplace, your manufacturing, and also your office workplace. 2005, we started this program called the Swim to Lean program, which is our 5S program. It was a fun program to introduce the concepts of 5S, and we broke the plan into multiple sections and created a fun competition, right? So there was weekly audits that were happening, and scores, and whoever scored the highest would win an award. So it's very important that we also celebrate in our journey, right? So for the culture, every small win you have to celebrate. So we measure our improvements and celebrate success with the highest winning teams. And we started, once we went through our 5S, we started creating standard work and creating flows, right? So when it comes to creating flow, it's called CCF, creating continuous flow. Creating flow is about how do you make sure that your product is not getting stuck within your production environment, within your cells. If you start building a car, from the time you start with the chassis until the car rolls out of the manufacturing plant, the car should never stop. It is on a continuous movement, and then things are getting done to that car as the car is moving, and it never stops. So that is called creating the flow within your production cell. For that, you need to understand your customer demand. How many pieces of that widget do I need to make in a day? That's the bottom line, right? If you don't understand your customer demand, if you don't understand your market, you cannot design your production line. You need to know how many people you need to put on the production line. You need to know how long does it take to create the product. So you understand the customer demand, and there's a concept called takt time, right? That you calculate based on your customer demand. How often do you need to get that widget out of your cell? For example, we were at the Toyota plant a couple of months ago. The takt time of that plant is 52 seconds, which means every 52 seconds, a Toyota car comes out of that factory, right? So every 52 seconds, that's the takt time. Now you know what your customer is expecting. You need to produce a car every 52 seconds. Now you have to calculate your cycle time. How long does it take me to build that widget? If it takes me 104 seconds to create that widget, that's my cycle time. I need to be sending that to my customer every 52 seconds, which means I need 2 people building that unit. So that way I can get 1 unit every 52 seconds. 104 seconds divided by 52 seconds, 2. you need two people or the two machines to be able to create that widget, right? So understanding your customer demand, understanding how long it takes your product, then balance your production lines, right? So we have production lines that work with about 20, 25 people on the production line. Now, how do we know we need 25 people? That's because we do a CCF event and follow all this exercise to define what each person would be doing and make sure that every single station in that production line is below the takt time, below that 52 seconds that is needed, that is being expected by our customers. So every single station has to be below that takt time, right? That's called line balancing. Once you balance your line, then you create standard work and make sure that that is standard for the line and everybody's is trained to it. So we started doing our CCF events back in 2005. And you can see the line that I initially showed, right, where all the product was, in front of the operators. There's the operator had to go bring his own materials. Now it's in a straight line where, product is moving from one end of the line to the other end, right? So this operator makes the product, pass it on to the next operator who builds it, and then pass it on to the next operator, and so on. But now there is flow that is going on. And every time we see somebody waiting, we know there's an opportunity, right? So waiting time is not good. That person is not adding any value to our customer. So that's waste. But this makes that waste visible, right? So going from a batch.
Avinash sir, good afternoon.
Yes,
sir,
please.
Sorry to interrupt. A little bit of suggestion I would need for this.
Okay, yeah.
Sir, in these cases, the lean manufacturing system, when we are adopting here, that there is a sandwich is coming, that is the just-in-time application with the lean manufacturing. Is it the right platform here? What is your observing? You are showing this one, that is just-in-time implementation along with the lean manufacturing.
Yep. So just-in-time is a concept of lean manufacturing, right? So you're producing the right product at the right time in the right quality that the customer wants, right? So
this flow is what you are telling now. This is the flow is a mapping with the JIT, right?
It's part of the JIT concept, right? Because JIT also includes material flow, which we'll get to in a minute, right? So material flow is how do we bring material from our suppliers to your manufacturing.
Sir, it is also the semi-product flow in the manufacturing that particular stream also, no?
Yes, this one is a product, semi-finished goods into the finished good product. So what we're talking about here is that finished good product going out. So
yes,
just-in-time manufacturing is you're not carrying a lot of inventory, right? You don't have any inventory on your products.
Right, sir. Thank you, sir.
Sorry, go ahead.
Thank you so much, sir.
Yeah, of course. Just to add on to it, right, and we'll get to it in a little bit as well, is material flow, making materials flow. So making sure that your supplier is providing you the right material with the right quality at the right time, so you can build your product on time as well. So ideally, you don't have any raw materials in your product. Ideal case, you're building one car, you only have one tire in your manufacturing plant. Sorry, 4 tires. So you need 4 tires for your car. So you only have 4 tires for your car when you're building it, right? If you have 4,000 cars and you're only building one car, the other 3,996 tires are a waste. Just-in-time manufacturing says that you only have four tires, and your supplier is sending you these 4 tires because you build this one car. By the time you start building your next car, you have your next 4 tires in front of you. Right, that's just-in-time manufacturing. We'll get there in a little bit because that also has to do with MMF, which is the next concept that we'll be touching. So in CCF, now you understand your customer demand. You understand how much product you need to be building every day and how many people you need to build. Now you need to take variation of the process, which means what we see on the left side here does not work. Right, your inventor, the operator, is stepping out of the line to bring his own material. And what we see on the right-hand side is inventory is being fed from the back side, right? So people are coming in and then feeding in material from the backside. So these people never have to, these operators never have to leave their lines. All they're doing is building their products. And then somebody else is delivering materials to them. But again, this is part of the just-in-time concept as well. Only the right material is delivered to them at the right time. In this case, they're building a pump. they are building an almond pump here, what you can see. They also build a black pump, but they only have the almond parts in front of them. By the time they change to the black pump, another black pump will show up in front, right? So there's a lot that happens in the background to make sure the right product gets in front of them. And it has to do with your production scheduling process. How do you make sure that you have the right signals through your material handling and then bringing the right material to your production lines to make sure that you're building that right product, right? So there's a lot that happens in the background at a very high level. This is CCF and line balancing, right? Another concept that you would see also is U-shaped production lines. So you have multiple shapes of production lines. So you have a straight production line where your product is going from one end to the other end in a straight line. What you're seeing here is an example of a U-shaped production line. So we started moving some of our lines to a U-shaped lines, right? So U-shaped line, the advantage of a U-shaped line is there's less walking, right? Which is a waste. As you're walking, you're not transforming the product or information, which is a waste. So with U-shaped product, you can balance your lines easier. You can move your people from one spot to the other spot easier. You can move your material from one spot to the other spot easier. So there's this concept of U-shaped cells. Now, U-shaped does not apply everywhere, right? Not all the lines can be U-shaped lines. You have T-shaped lines, you have straight lines, you have X-shaped lines, multiple, but the most commonly used application for U-shaped lines are for smaller cells, where you need to be able to move lines, you need to be able to move your people around quite a bit because your demand is changing, the seasonality of the business, right? Sometimes you have to run the line in January, you may have to run the line with 5 people, but in June, you may have to run the line with 15 people. In this case, our Moore Power Plant makes swimming pool equipment, right? So they make heaters, filters, automation systems. So it's a very seasonal business. In the summer, they will be shipping out $8 million a day. But when it comes to the winter, they'll be shipping only $3 million a day, less than half of what the demand is in the summer. So it's very important for these lines to be flexible, to be able to run with 5 people and with 15 people as well. So U-shaped lines make a lot of sense. In 2006, right, once we have CCF, once we went through the whole production line, we started making these changes, right, and then making sure that we have flow within the cells. Then we started the next concept, which is step number 6 here, material flow. How do we make sure that we have that right material coming in? There's a 4-wall material flow and outside the 4-wall material flow as well. 4-wall material flow is from your warehouse to your production lines. How do you make sure that from your internal warehouse, because material is stored in a warehouse, you bring from that warehouse into your production lines to transform it. And then once it's transformed, you move it into a shipping area and ship it out to your customers. So the transformation happens in your production lines, but there is a warehouse where you're holding that inventory. Now, that warehouse is absolutely non-value add, right? So if the more inventory you're keeping in your warehouse, the more waste you are carrying. So the next concept is, how do you reduce that inventory, right? So first, make sure that that inventory within your 4 walls is flowing smoothly. So we use a concept called material flow within the 4 wall through your tugger system. So there are internal Kanban cards. Kanban is a Japanese term for a signal, sorry. Kanban means signal in Japanese. So you only move material when you get a signal to move that material. So a Kanban card. So if I give a card to you, you give me that material. So there is a lot of math behind how do you calculate the number of cards that you need. It's called a loop, right? So you have a finished good loop where you're moving your finished good. You don't build a product until your customer has pulled a product from your shipping warehouse, right? So they pulled a heater from our warehouse. We build a heater and put it back into the warehouse. Now we have to have a finished good warehouse because the customer demand never comes flat, right? The customer never orders 500 heaters every single day. One day they order 300 heaters, another day they order 800 heaters. So there's variation in customer demand. And to absorb that variation, we need some kind of an inventory, but it's controlled inventory at that point, right? So you carry a couple of days worth of inventory. So when a customer orders 700, you still have inventory that you can pull from, and then you backfill that inventory. And then if the customer does not pull enough, then you stop your production lines because you don't have a signal from your shipping warehouse to produce more. So that's a pull system on our finished goods. Now you have a pull system loop on your raw material as well. You don't deliver raw material to your production lines until your production line needs it. So I consume a part, my raw material warehouse delivers a part to me. And I send a signal back saying that, hey, I need you to send me another part, and then they bring me the next part. So if I don't send them the signal, if I don't send them the Kanban, they will not deliver the product to me, right? That's the material flow concept. So initially, material flow used to happen with forklifts. Right, so this is an example of a Kanban card. It shows, okay, where to pull the material from, where to deliver the material to, how many pieces to deliver, how many cards are in the loop, and all this information. So this is an example of a pull system or a pull signal that we use internally within the Moore Park operations. That's internal Kanban, right? So once you have the 4-wall all cleaned up, then you go external Kanban as well. So from your suppliers. Previously, I think a gentleman asked just-in-time manufacturing, right? So with just-in-time manufacturing, if I'm holding 100 days, which Moore Park used to hold 108 days of inventory, all that inventory is sitting there, and that's cash tied up, right? You paid money to hold that inventory, and it's not paying you back. So just-in-time inventory is get all that inventory out. You're not carrying all that cash. Your cash is not tied up, and you partnered with your supplier. It's not a supplier anymore. It's your partner, right? You partnered with them to make sure that they're delivering the inventory that you need at that right time. That's external material flow. So once we have your 4-wall material flow, then you start Kanban with your suppliers. I will send you a signal, then you send me the product only when you get that signal. If you get that signal, you send that inventory to me, and then I'll consume it. Once I consume it, I'll send you another signal, and you send that inventory to me. There's a little bit of safety stock between the two, but it's the same material flow concept that you use externally at that point. So you can see, right, we took off all the racks from the environment. We removed inventory out of the production lines. Now, material comes in from one side of the production line. It goes through the production line, and then this is the finished good market where shipping would just come pull the inventory. Now, people are working inside the lines. They are not stepping out of the line to take materials. We have people, in this case, we used to have what are called local markets. Right next to the line, we had a warehouse would drop material, and then we had an internal material handler called the water spider that would take the material from the store into the line, so the people never have to leave. Now, once you introduce the concept of material of tuggers, then all this goes away, and then you're bringing material straight from the warehouse into the production lines. So again, injection molding, started working on injection molding a little bit, started having 5S cleanup organization within the injection molding area. Then in 2008, we started external material flow, right? So this is when we introduced external Kanbans. We introduced the tugger deliveries. Tuggers are trains, right? So we took away all the material markets that were next to the lines, and that opened up a lot of space in our manufacturing environment at that time. And we started delivering material through Kanbans signals through tuggers. That eliminated forklifts on the production floor. This is an example of the first tugger that we had in this building about 17 years ago, right? Now the tuggers are much different today. They are much more organized. But this was one of the first Agar where material was being delivered from the warehouse to the production lines with one person, where we had 7 people delivering material to 7 different lines. One person would deliver to all 7 lines.
Avinash sir, what is the importance of this implementation? Only to control the waste only?
Yeah, everything is waste elimination, waste reductions, right? You have to produce your product at the lowest possible cost, and the cost is not just coming from your manufacturing. The biggest cost is coming from outside what happens within the manufacturing cell. The biggest waste is actually coming from material flow that is happening, right? So by streamlining your material flow, you're taking all that waste off. We used to have about 50 material handlers that would move material from one place to the other place. Today, we have about 7 material handlers that do this transaction, right? So you took away cost of manufacturing of that product.
Very good. Okay. Sir, is there any, like your process control chart, or you can say that non-conforming item or defective item, is there any control on these things we are observing through the lean manufacturing?
Right. So we follow what is called the SQDCC, right? So SQDCC are our metrics: safety, quality, delivery, cost, and cash. In fact, that's a great question. Thank you for bringing it up, because that goes to our next topic here. So these are the control charts that we use on the production lines to ensure that that we are within our limits. Right? We have our targets. If you go beyond our targets, then you have your red, yellows, and greens. You want to be in the greens. Yellow is the warning zone, and then you go into the red. Then that means that, hey, you know what? So watch out. 2 days in the red, then we require root cause analysis, right? So somebody has to step in and do a root cause countermeasure and create a countermeasure for that activity. So this is called MDI, Managing Daily Improvement. So we have this for safety, quality, delivery, and cost. And there are different metrics. For safety, for example, we measure the number of suggestions. It's not incidents, right? If we measure incident means like a safety incident, somebody getting hurt. If you're measuring incident, it's already too late. Somebody already got hurt. So what we measure is suggestions, right? How many proactive suggestions that we have that have potentially eliminated a safety incident from happening. And then we have targets for that, right? Everybody has to submit X number of suggestions on a daily basis. And we measure red, yellows, and green. Same thing with quality. For quality, there are process control charts. Depending on the area, each area would have, the machining area would have control charts, right? Process control charts where, they're probably measuring a diameter of a, machine component. And that diameter has to be within tolerances. And then, they chart out, is it getting closer to the upper limit? Then, you take action. They have CPK that they will be measuring on a periodic basis. Now, remember, this is 2008, so we were all doing this manually on paper, right? You can see this lady, she's one of the team leaders in that area, that she is actually measuring it, and she's, in this case, reporting out on her SQDCC, so safety, quality, and so on. So she is reporting out on her SQDCCs. So this is more visual management. Anybody can stand in front of this, and then they can say, are you doing okay? Are you not doing okay? Are you in the red? Are you in the green, right? So a very quick means for us to say if our processes are on control or if we need to take any action. We measure every single metric, SQDCC, on an hourly basis. In this case, this is production performance, right? So as I mentioned previously, if my customer is asking me to ship out 50 heaters an hour, I better be producing 50 pieces and 50 heaters an hour, right? So we measure this on an hourly basis. Any hour that we miss, we need to mention as to why we are missing it. Now, not every day we need to have RCCMs, but this goes into this control charts. If I have 2 days in the red that I miss my targets, then I would ask the team to get together to understand why we have a miss and how do we fix the root cause so it does not happen again. Sometimes we don't have the right material, or sometimes the dugger driver is late delivering the material, or there's an equipment failure, whatever that is. 2 days of the same issue happening would need the cross-functional team to do root cause countermeasure. So this is the last step right in that cycle, right? You've done all your work. You've created your strategy. You created your transformation plan to hit that strategy. You organize your workplace. You created a standard so you can measure improvements. Then you do your CCF. You create flow within your manufacturing cells. Then you make sure the next step is delivering the right materials from your suppliers to your plant warehouse, to your production lines. Once you have all that, the last step is you're managing your daily improvement, right? You're making sure that you're measuring your processes and you're taking countermeasures if your processes are going out of your controls. So this is the PDCA, the 7-step PDCA approach. So with this, in 2008, we wrapped up our first cycle, right? So this is an example of how the shipping area looked like, a lot more organized compared to 2004 to 2008, a lot more organized, not a lot of inventory. We saw in the previous examples, a lot of double stacking, in this case, FIFO lanes and single stack product. And then we get into 2009, which is a second iteration of the lean journey, right? So first iteration was stabilizing, making sure that we understand customer demand and all. And second iteration is around culture. How do we enable that culture and making sure that now instead of some team leading these events, now you have every single person within the organization doing this improvement on a daily basis. That takes your organization to the next level, right? So this is focus on culture in the next level. Plus, starting some advanced lean tools, right? So TPM, total preventive maintenance on your big machines, right? Making sure that you take care of the machines before they fail. So there's a lot of activity that needs to happen to ensure that your product is not failing. So as we did all this activity, we opened up a lot of production space, right? So we grew from a $300 million organization. This plant grew from $300 million to $1 billion organization, right? Within the last 15 years. And we opened up all this extra space through this continuous improvement and Kaizen methodology. In 2010 is when we started our first outside the four-wall methodology. Lean is not just limited to us. We are as good as our partners are, as our suppliers are, right? So for us to be successful, our suppliers need to be successful. They have the same kinds of ways that we used to have. So we started a program called the Supplier Lean Development, where we had teams of our resources, our team members, our managers, our team leaders that would visit our suppliers, work with our suppliers, do value stream mapping at their locations, do the CCF events at their locations, right? And now connect their location to our location through Kanban cards, through signals, through pull systems, right? So 2009, this was a second iteration. We went outside the four walls and started connecting our factories to our suppliers. Started working on this culture. We started what is called the Lean Lean Development Program. So that's where our next level leaders were being trained on running their own events. Our team leaders, now expectation is every single team leader who is an hourly associate, they're not salaried people, right? They're not engineers. They're hourly people that run their own Kaizen events. So that's the Shingo methodology that we started our journey on. So in 2011 is when we introduced that Shingo methodology. Culture change champions, our journey on zero landfill, right? And we continued our Kaizen events, more TPM, visual management. You can see how the factory is transforming, right? Much more cleaner, much more defined material handling routes, much more organized production lines. And then 2012, we challenged the Shingo, and I don't know if anybody knows of Shingo. So Shingo is a branch of Lean, right? Is a major branch of Lean. And to get a Shingo award, it's called the Nobel Prize of Manufacturing, right? So Shingo it's given to very few organizations every year, 3-4 manufacturing locations across the globe per year. So we challenged Shingo in 2012, and it's a very rigorous exercise that Shingo goes through, right? So challenging Shingo means that your culture, you're doing lean every single minute within your organization, right? So you are a beacon of lean in the global operations world. To introduce an employee suggestion program, right? Every time an employee sees an opportunity, they have the power to fix it and then document what they fixed. And we called it an employee suggestion program, or the PAWS program. Was the first year that we launched the PAWS program. In 2013, this side, the Moore Park side, won the Shingo Silver Medallion. That year, we had Goodyear won the Shingo Prize. The Pentair site in Moore Park and a Toyota facility in Canada won the the Silver Medallion. So this was a proud moment for this site, for being recognized, for being a world-class lean facility. This was the second site within Pentair that actually won the Silver Medallion. Then this is where we started our Lean Leader program, which is now our second level leaders being trained to be those lean champions. Again, more continuous improvement. Every year we started opening up more floor space, and this enabled us, because Pentair grows through acquisition. This enabled us to move more of our acquisitions into Pentair, right? So there is a concept called 3P. 3P is pre-production preparation, where you are relaying out your production area. So you're relaying out your production plants to make sure that you have the right flow within the plant, within the four walls. Then in 2014, we started our third journey, right? So PDCA, first cycle done, second cycle done, third cycle starts. This is where we started our automation journey, the level 3 automation. This is, we focus on injection molding to start with, right? So this is where initially this plant had about 30 some injection molding machines, and there was one person running each machine. So we started introducing robots. Now injection molding works 3 shifts, 7 days a week, so 24/7 operation. So much easier to justify the investments. Now robotics take a lot of investment, a lot of capital investment, right? So you need to be able to justify it. Injection molding is easy to justify. So we started off there, and out of the 33 machines, we put 25 machines on pick and place robots. So that took away all our assembly operators, right? So instead of 30 people running 30 machines, we have like 6-7 people that run the 30 machines because of these automation improvements that we did in the journey. Now, note that as we are doing this, we are still doing more CCF events, right? The CCF events never stop. You're constantly rebalancing your production lines. But at the same time, where you saw a lot of manual operation, now you're introducing some automation into the factory floor. A lot of fixtures, automated fixtures, that part locators. People don't need to be holding parts, right? So you have fixtures doing that for you. All the repetitive tasks are taken away from operators and now are being automated at this point. That again takes more variability out of your operation, right? A repetitive task is you're putting a cap on a bottle. You don't need a person to be putting a cap on a bottle, because the person takes 5 seconds at the beginning of the day, but that turns into a 15-second operation at the end of the day because he's tired. Robots never get tired, right? So that's where we started the third. Now 2020. Sorry, this circle is wrong. It has here. So 2020, we started our fourth leg of the transformation, which is Industry 4.0, right? So we brought in, we created a team called AMET, Advanced Manufacturing and Engineering Technology. And, we created an assessment across all our Pentair locations, right? And they visited every single location, graded where each of the facility is in their manufacturing journey, in their lean journey, in their Industry 4.0 journey, and then created plans for each facility. So within Moore Park, then we started introducing robots into assembly lines now, right? So previously, in the previous cycle, it was injection molding, heavy injection molding focused. Now it was assembly lines, and you could see that there's a cage around this robot, and this is an important observation to be had here, right? So robots are also potential accident opportunities, right? So they do not know that people are around them, and people could get hurt. So either you put sensors in that area, or you put the robot in a cage so nobody interacts with that robot or can get hurt. So when we first started it, our assembly journey into more automation, we had to put cages around the robots, but this let us take more variation out of our process, more labor out of our process. We do a lot of plasma welding, which is a little dangerous, and robots, again, are much more safer to operate on. A lot of repetitive acts taken away, from the team members. If you remember this picture, we had people filling our control charts with paper and pencil, which is very important. That is how we have to start. People have to understand with your paper and pencil, and do that rigorously before you take it away from them, so they understand the concepts, right? So we started automating some of that, right? So now this is where your big data and real-time analytics would come in. So as you produce a part, you have real-time display of this, and then nobody has to wait. There's no delay from the production line to getting to this paper. It's automatically displayed. All your metrics are right there on the display right next to the line, so the people on the line can see it, and also for the managers to be able to analyze the data that is coming through, right? So real-time hour-by-hour charts, real-time data analytics that are available, that we started in our 2021 digital manufacturing, digital factory journey, right? So the one on the right is replaced by the one on the left. We measure equipment effectiveness, downtime of the equipment, the performance and the quality of the equipment. Then in 2022, we started a journey from our sub-assembly lines into our main assembly lines. You could see on the left, this was one of our assembly lines where we had multiple people putting a product together. This is a control system that they're building. To the one on the right, it's a completely automated cell. There's not a single operator that's on the cell right now, right? So you just have material handlers that are feeding material, and then the automation assembly happens inside the equipment, and you get the finished product out, right? So going from semi-finished product into a finished automation cell. Now we started using cobots, right? So cobots, where you want human robot interface, right? So where they need to share a workspace, then use collaborative robots or cobots. Now this does not need to be in a cage. This robot has sensors, so if you touch the robot, it knows that somebody is right next to me, and it stops. So we started introducing cobots into our manufacturing lines. Now people and machines can work together and interact with each other. And the next step was AMRs. So AMRs these are automated vehicles, right? These are forklifts. In this case, this example is a forklift without an operator. Sorry?
Avinash sir, I want to take one suggestion here.
Yes, please.
Sir, in the previous slide, the use of the cobot. Yes.
Yeah.
So what is why you want to introduce the cobot here, sir?
So if we look at a previous example, right? So
yes.
In this case, we have a robot in a cage, right? So this operation is completely okay because the robot can perform the operation by itself, and it does not need human interface. If a human has to interact with this robot, they have to open the gate. As soon as the gate opens, the robot stops working, right? Because it's not safe for the person, because the robot's moving very fast, right? It just keeps on moving, and it's hard. And if there's if it hits a person, it could be a serious accident. So that's why you have to enclose it in a cage. This is okay when you're working in a sub-assembly station, which is taken away from the main line, and it's working by itself, and it's feeding the main line separate through conveyors, right? But when we come to main lines, if it's a cell that is completely automated like this one, we don't need those. But if there is human interaction that is still needed, that's where we use a cobot, right?
Sir, is the role of the cobot is the cobot operation is the same as a general robot in the manufacturing floor, or it will only measure used for the measurement of the quality here?
It just acts like a regular robot. These are smaller though. These are not as big as the other heavy duty robots. So they can only lift up to 30 pounds in weight, for example, right? So they're slightly smaller, but they fit in a human space and a human environment. So they cannot do everything that the bigger robots do, but in a light assembly, they can perform the task that we require them to.
Okay, just like in mobile assembly lines, like that.
Yes. Yeah, a perfect example. You're right.
Right. Okay, sir.
Yeah.
But it's the same function in the general streamline, not in the particular assembly of the heavy metals, sir?
Yes, it applies anywhere. It applies to your injection molding, right? So again, the robots have existed for a very long time. Cobots are relatively newer. They started in the last 10 years. Right, so these are relatively newer compared to
actually generally what I got from other information for the industries, or these cobots are generally they are using for the providing the service in the, just like in you can say the inquiry purpose or etc. like that.
Okay. You can use them in assembly lines as well, right? So assembly lines, so for example, when we build a product, right, the production lines are timed in such a way that in one station there are no two people at the same time that are working on that area. So you still have like that when the person is doing that operation on that line and then walks away, the cobot can come in and then finish the assembly there. The cobot
are they using for the pelletization, sir?
Sorry, I don't know what
leveling and pelletization or barcoding, measurement, etc. they are using in the industries.
Could be, but we don't use them. We do use cobot for packaging and light assembly. Yes.
Exactly, packaging. Okay, sir. Thank you so much.
Yeah. Thanks for the question. Automated mobile robots also is an example of a robot that's in one of our facilities, right? So this is like autonomous cars that we have on the streets right now that are being tested on the streets. These are automated forklifts that actually move material around. We don't need people to be moving material around. Similar to these automated forklifts, we have automated tuggers that will actually deliver material to multiple lines at the same time and pick up material from multiple lines at the same time as well. So the difference between a forklift and a tugger is a forklift is like a taxi. You can only pick one pallet at a time. A tugger is like a train. You can pick 100 pallets at a time, right? So we have both automated robots and automated tuggers that perform this job. Now, so our goal here is for this year, we're introducing the automated tuggers and the automated cobot, the robots in 15 of our manufacturing locations. And these are completely connected. So the systems talk to each other, and they also talk and deliver information to a centralized system. We're also doing an ERP migration. We are going away from a 25-year-old ERP system to SAP, and which is a major initiative this year. And the SAP is our first step in our building our digital stack, right? So there's a lot more that we could do with SAP. There's a lot of data and reporting that SAP has compared to our previous ERP system. We can tie SAP to multiple other systems like Salesforce, and our warehouse management system can completely be automated right now. We do not need anybody to go and pull material from our warehouse. SAP and our WMS system can talk to each other. The robots can go pick up material because it knows exactly where that material is by interacting with SAP. So it's the first step in our multi-year digital transformation effort for Group. So looking forward, 25 and beyond, our key goal is to automate our material handling. As I mentioned previously, material handling is where majority of your waste is, and we need to optimize that material handling. So through these AMRs, it's going to be a big step forward. And connecting our SAP to our outside system, the third-party systems is the next step that we're looking forward to. And then we are looking at a lot of AI tools that we could use within customer service to automatically answer calls, use the big data that is being generated to create those leads for our marketing teams and the sales teams. So there's a huge AI effort that is going on. We call them the growth streams. That use these AI information and then eventually trickling down to our customers through the use of this AI through an effortless pool experiences. How do we connect all the different pools that are out there in the world and have an effortless experience with our customers? So that's been the Pentair journey. I apologize, it's been a long conversation. But if anybody has any questions, I'm open to the questions. I hope you all learned something from our last 25-year journey. Again, Lean is not about repeating the journey, but it is learning from others and making the journey faster. Toyota is where it is today, over 50 years of Kaizen events. We want to learn from Toyota, and what took Toyota 50 years should take us 5 years, right? And in the next company that learns from Pentair should take them a year for that same journey, so they don't have to reshape it. So hopefully all of you learned something from this journey, but I'm open to any questions that you may have.
Yes, Avinash. Thank you for number one, going through the journey of implementation of Lean and achieving the level of today's and for future ready.
Sir, good afternoon.
Second thing, definitely wonderful presentation, which I enjoyed, learned. I had been the part or member of Lean implementation in HAL, Hindustan Aeronautics, during the time you started 2004. We had been from 2000 onward. And the one roadblocks has been every supply has a lead time. How do you accommodate? You give the signal, now other fellow will have lead time, other fellow also doesn't want to store it, he will go for his supplier, another chain of supplier. Now how do we take the lead time of this so that everyone maintain JIT or on time, instead of one place is stored and then one signal you are getting but others are not able to. So someone is paying for possibly your company to supply on JIT. Is it?
Yeah, no.
Yeah, clarification. I look forward. Thank you.
Yeah, thank you, Gupta sir. That's a great question, right? It's a journey. It's not something that happens overnight, right? So again going back to our journey, right? We started within the four walls, right? We started within the four walls and we leaned out the plant first, making sure that our lead time within the plant came down, right? That's the first step. And if every company does the same up the value stream, right, up the value chain, your suppliers, the suppliers, tier 2, tier 3 suppliers do the same thing, right? So we are the OEM and we have your tier 1 suppliers, and they have their tier 2 suppliers, right? The first step is to reduce that lead time within the value stream, so they understand the customer demand. So our on-time delivery, even though we are carrying 100 days of inventory, we are only delivering to our customers 50% of the time. It's the same thing with our suppliers as well. So imagine the same journey where we cut off today from 109 days, we are at 35 days of inventory, right? Which actually went up. We were at 20 days of inventory before COVID, and we're at 35 days right now, post-COVID, because of the lead time increase and all that, right? But with reduction in that inventory, we are at 90%, 95% on-time delivery to our customers, right? We are able to serve our customer better. It's the same concept that goes to your suppliers as well. If the supplier is lean, it's the exact same thing. We don't want them to be carrying 100 days worth of inventory. We absolutely don't want them to. We want them to be profitable as well, just like how we are profitable, right? Unless they are profitable, we cannot be profitable. So we help them out with their lean journey, bring down their inventory levels, bring down their lead times, So that way they can supply the inventory that we need at the price that we want them to, at the lead times that we want them to as well. So we do ask them to store inventory for us, finished goods inventory for us as well. But we have supply agreements that limits their liability, limits our liability, and making sure that we are pulling from their stored inventory, right? So through this Kanban, 80% of our raw material supply is on Kanban, on a pull system. So when we send a signal, the supplier has that inventory ready because we have a supplier agreement for them, and they ship it to us. But at the same time, their inventory levels today, because of what happened within their four walls, is much lower than what it was 20 years ago because of all these lean improvements. So you take that journey up the value chain until it doesn't pay back anymore.
Thank you. I was the head of materials division for one of the lab division of HL. I was material department. And for this, we accommodated in terms of having the contract for supply for long term, 5 years hence, 10 years hence. Our planning has gone so much back that 5-year supply forward, we set up the contract and then they planned accordingly. So that time reduction of lead time was possible. And I think you also explained in a better way, it is a journey, it's not a one-time cutoff. And therefore slowly reduction in lead time as well as inventory both happens. Thank you very much. Wonderful presentation of your own case study. And definitely learnings are plenty for everywhere. Thank you.
Thank you very much, sir.
His presentation, I mean, on the lean manufacturing in industry 4.0, we got deeper insights, and he shared thorough knowledge regarding his topic. And I think participants got immense knowledge through his session. And thank you very much, sir. Yeah, you may leave, sir. I mean, we have another session is waiting for 2 minutes to go, actually.
Okay, sounds very good. Thank you very much.